Hello ma'am, our batch is going to present a topic on inverse Z transform. So the speakers are Bharat, Naveen Raj, Nitin Christopher and Vijayan. The overview of our topics are: first thing is causal system and Z transform in causal system. The second is non-causal system and its explanation. The third thing is problem in causal system, and the last is problem in anti-causal system. So first, what is inverse Z transform? It is to analyze a system which is already represented in frequency domain as discrete time signal. Then we go for inverse Z transform. Mathematically, it can be represented as x of n equals z minus 1 x of z, where x of n is signal in time domain and x of z is the signal in frequency domain. So what is causal system and the Z transform in causal system will be explained by Naveen Raj.
A pleasant good morning to all. I am Naveen Raj. My roll number is 18232. I am going to explain about how to determine a system is causal and stable based on Z transform. I am going to categorize the system into stable or causal system depending upon the behavior of impulse response. And here h of n is the impulse response and h of z is the system function and also known as transfer function. H of z is equal to z transform of output divided by z transform of input. So h of z equal to y of z divided by x of z. For causal system, the impulse response, which is nothing but h of n, should be 0 and n should be less than 0. So that h of n is a right-sided sequence. That means the ROC is outside the outermost pole. Here we can see the poles A, B, C, and the ROC is outside the outermost pole C, and the picture in the right side is the right-sided sequence. The condition for the system be causal is ROC should be outside the outermost pole. And now we are going to see about the condition for stable system. The condition for stable system is the summation of k equal minus infinity to infinity h of k should be less than infinity. That means the h of k should be absolutely summable, and also the poles should lie inside the unit circle in z plane. So the system that satisfies these two conditions are called stable system. Now we are going to see about the condition for the system that is both causal and stable. And the conditions are: the poles should lie inside the unit circle in z plane, then the causal system is stable, and the ROC must include the unit circle, and the ROC must be outside the outermost pole that we have seen already. And this is the example problem for non-causal system. Here h of z equal 2z plus 1 divided by z square plus z minus 5 by 16. When we solve this equation, we get two poles. The one pole is minus 5 by 4 and the another one is 1 by 4. When we plot these poles in the z plane, the minus 5 by 4 is outside the unit circle, so it doesn't satisfy our condition. So it is a non-causal system. And look at this example problem. H of z equal 1 plus 2z power minus 1 divided by 1 plus 14 by 8 z power minus 1 plus 49 by 64 z power minus 2. When we solve this equation, we get only one pole, z equal minus 7 by 8. When we plot this pole in the unit circle, the pole is inside the unit circle, so it satisfies our condition. So it is a causal system.
Hi, I am Vijayan, 199436. Today we have to discuss about non-causal system.
Hi, I am Vijayan, 199436. In this video, we are going to discuss about non-causal system Z transform. Non-causal means for a non-causal system depend upon future input, that is known as non-causal system, and a non-causal system is otherwise known as acausal system. Non-causal system is just opposite to similar to causal system, and at any instant of time the system is said to be non-causal system. For example, y of t equal to x of t plus 1, y of t equal to x of t plus 1. We have already discussed in the system, causal system, if we can put t equal to 2. So y of 2 equal to x of 2 plus 1, y of 2 equal to x of 2 plus 1, y of 2 equal to x of 3, x of 2 equal to x of 3. It will reduce to x33, which future value, that is non-causal system. Another example of non-causal system. Here y of n equal to x of n plus 1 by 2 x of n plus 1. This is a system. Check whether calculate this is causal or non-causal. Here also we can substitute any value. Take the value n equal to 0. Y of 0 equal to x of 0 plus 1 by 2 x of 0 plus 1. Forever present 0 we are going to depend upon present input. So x of 0 plus x of 1 will be given answer, will become future input. So that is known as non-causal system. So that means 0 is present time when we are going to give x of 1, that may be future input to x of 0. So the system response always depend upon present input and future input. That is known as non-causal system. I will give some important points. All non-causal systems are dynamic. Why I am saying like this means, when your system is set to non-causal, whenever it output responds to depend upon future input, so that is said to be non-causal. So if your system depend upon future and past, then you need to maintain memory, then the system is dynamic. So all non-causal systems are dynamic, but all dynamics are not non-causal, because dynamic is a memory. Example, system is depend upon present and past input, then that is also dynamic system. That is not set to non-causal. That is known as non-causal system. Thank you.
I'm Bharat. My roll number is 18209 and I am going to present a topic on inverse Z transform, a problem and a solution to the causal system. So this is the problem given to us. The question is, determine the inverse Z transform of x of z using long division method for both causal and anti-causal system. So I am going to explain the solution for the causal system. Before going to the problem, I am going to tell you an general idea about the causal and anti-causal system for a Z transform. That is, the region of convergence for a causal system is greater than 1 and for a non-causal system is less than 1. So now looking to the problem, the question is x of z equals 2 plus 3z inverse plus 5z power minus 2 divided by 1 minus 3z power minus 1 plus 4z power minus 2. So by using a long division method, we can get a solution to this problem. First thing is multiplying the 2 with the denominator, we get 2 minus 6z inverse plus 8z inverse 2. By subtracting the acquired equation with the numerator, we get 9z inverse minus 3z power minus 2. Again multiplying with the denominator with 9z inverse, we get 9z inverse minus 27z power minus 2 plus 36z power minus 3. Again subtracting, we get 24z power minus 2 minus 36z power minus 3. So we can perform this operation continuously, but we have to stop at some point. So I stopped here at 4th operation, that is after performing 4 operations I stopped it. So after these 4 operations I got the equation, that is x of z equals 2 plus 9z inverse plus 24z power minus 2 plus 36z power minus 3. So I here written a condition for x of n, that is x of n equals 0 for n less than 0. So x of 0 equals 2, x of 1 equals 9, x of 2 equals 24, x of 3 equals 36. So the combined view of x of n is 2, 9, 24, 36, etc. then this is the solution to the given problem, and 0 starts at 2. Then the problem and solution for the non-causal system will be explained by Nitin. Thank you very much.
Good morning. My name is Nitin Christopher. My roll number is 89235. And in today's presentation, I will be solving the inverse Z transform of an anti-causal system. Thank you. Good morning. I am Nitin Christopher and my roll number is 89235. And today I will be explaining how to solve inverse Z transform of a given system, which is an anti-causal system when x of n is anti-causal. Okay, so before diving into solving the sum, what we have here is what is an anti-causal system. Before I explain what is anti-causal, I'll tell you what causal and I'll give you a brief about what causal and non-causal is. Causal basically depends on the present and past inputs, while non-causal depends on future inputs. It also depends on future inputs, non-causal. Whereas in anti-causal is only dependent on the future inputs. So there is the key difference between anti-causal and non-causal is the difference in inputs. So non-causal is dependent on past, present and future inputs, whereas anti-causal is dependent only on the future inputs. So anti-causal, the region of convergence for anti-causal is mod z is less than a unit circle. So basically mod z less than 1. Before getting in, what we have here is we have to rearrange the question in a way that is suitable for solving to finding the inverse Z transform of an anti-causal system. So what we have to do is actually we have to arrange the Z terms in Z terms in ascending powers of Z or descending powers of Z inverse. So the given problem is x of z is equal to 2 plus 3z inverse plus 5z to the power minus 2 by 1 minus 3z inverse plus 4z to the power minus 2. So here we can see that the numerator and denominator are both in ascending powers of z inverse. We need to just reverse this equation to get to satisfy our condition, that is descending powers of z inverse. So, and after just rearranging, we get x of z equal to 5z to the power minus 2 plus 3z to the power minus 1 plus 2 divided by 4z to the power minus 2 minus 3z to the power minus 1 plus 1. And now let's dive into the, okay, so for the anti-causal system, we are using long division method. So we divide 5z to the power minus 2 plus 3z to the power minus 1 plus 2 by 4z to the power minus 2 minus 3z to the power minus 1 plus 1. So the denominator into 1.25 will help us cancel out 5z to the power minus 2, and we have a remainder as 6.75z inverse plus 0.75, and multiplying the denominator into 1.69z will help us get 6.75 z inverse, which will again lead to cancelling that out, and we have a further a remainder as 5.81 minus 1.69 z. So what we basically have here is we do the division process, we multiply it with 1.45 and we keep continuing it so long. We do it up to 4 terms, up to z cube, and up to z cube. We can keep doing this, but it's not necessary that we keep doing it. We can stop it here. So we have x of z as 1.25 plus 1.69 z plus 1.45 z square plus 0.67 z cube. And so we have x of 0 as 1.25, x of 1 as 1.69, x of 2 as 1.45, x of 3 as 0.67, and we have a condensed view of the answer. So x of n is equal to 1.25, 1.69, 1.45, 0.67, and so on and so forth. And this begins at the 0 is at 1.25. And this we have come to the end of our presentation. Thank you.